He has played diverse global client-facing roles, led transformation engagements for leading energy and utilities companies, leading industry thought leader around energy and utility, leading industry speaker and author of articles in leading industry journals around digital transformation, modernization. Let's welcome Mr. Rajeev Mittal with a huge round of applause.
Okay, my introduction is already done. So what we have been hearing, right, during the last 1.5 day, data, right? What to do with data? I think that's the main problem we are trying to solve. Data is now not like smart meter is one of the use case, but it's coming from, like, if you see oil and gas, other industries, right? Data is an issue where a lot of sensors, IoT devices, we talked about how they are getting introduced into a ecosystem, like in this case, electricity value chain, and how we can make sense of it, right? So that's the first thing. And the second thing is the future of, my friend showed a slide, future of energy, right? There are multiple sources of energy which will get introduced into the grid, and how again that will disrupt the whole grid, right? So to solve that problem, what we in discussion with our clients, what we have come up with is a hard asset or a solution, you can say, which we have developed, which is open architecture. It does not require any license. It's very open architecture, and it's on cloud. So I will talk about that in brief. The solution, it's available both on Azure Marketplace and AWS Marketplace. So it is platform independent. We have not included any technology. I'll just talk about that, and there is a video to end that we have created with the Microsoft. Okay. So next slide. Okay, so these 4 Ds you must have heard across. I will just summarize them. What we wanted to talk about here is like, we are in an energy transition stage across the world, including India, and the way we generate electricity is going to change. It's already changing, and a lot of renewable sources of energy are getting introduced into the ecosystem, right, in India as well. And I think our plan is to have 55% of renewable in next decade, right? That's our plan in India, and 500 gigawatts of renewable energy is being introduced in the system. Now, what that is doing is it is disrupting the grid, right? Utilities are struggling how these distributed energy sources needs to be integrated in the grid, and a lot of utilities are across the world. They are initiating this grid modernization programs, right? Like now, when they do grid modernization program, they essentially create a digital infrastructure. We talked about that. I think a lot of speakers talk about, like, we need to create a digital infrastructure. Now, once you create a digital infrastructure, like, obviously that will give you real-time inputs, real-time operations, electricity, how you consume them. So that is causing the disruption. Now, the other challenge is IT and OT, and I heard CT as well, right? The data is coming from these 3 kind of systems, and right now they are in silos. IT systems don't talk to OT system in most of the organization across the world. OT systems are provided by proprietary companies like GE, ABB, Siemens, right? They are owning those SCADA systems, and those are running in the utilities or the other oil and gas companies. And as I said, we need to break that silo, right? So to break that silo is this solution, what we have created. Let me talk about that. Just go next, this is not working. Okay. So typical challenges from a industry side. A lot of smart grid program we talked about, right? India is also in a smart grid journey. A lot of smart grid programs are being initiated, and what that is doing is introducing a lot of sensors, IoT devices, the volume of data, the velocity of data which is being introduced is disrupting, right? They don't know how to make sense of it. And the traditional platforms which are offering these the sensors are itself becoming cheap, right? And hence, more and more sensors are being deployed, and hence more and more data, right? But then what to do with that data? It's a real-time data. Even somebody talked about digital twin also, right? Digital twins are being set up across the world, and how to make sense of those digital twins, because they will again need real-time data. So real-time, near real-time or real-time data to test their operations, transmission, distributions. So that is a problem statement, and obviously it needs to be secure, There was a talk on security as well. And if the workload needs to move to cloud, how to ensure that it is secure, right? So these are the typical challenges we are trying to solve. Now, for IBM, what we are doing is this energy data hub, which I'm talking about, that will initiate a real-time orchestration on a secured environment, right, on hybrid cloud platform. And once you have this data, then you can run your intelligent operations over that data, which is combining IT, OT devices. All the data will come on that platform, and that will give you predictive insights to run your control room operations, field operations, and smart meter operations, right? So that is our vision. We have tested that with a couple of clients. I will talk about that. But this is our vision, and this we already started implementing with a lot of clients. This is a typical architecture for Energy Data Hub. Very open standards, Kafka, Spark. People who know cloud, they will know. Kafka, Spark, Kubernetes, this kind of interface will get combined with it will not have any problem in terms of interoperability. And then what we have done is, like, this is our proprietary rules engine. So once you ingest the data, right, from these systems, we have created a rules engine depending on, say, smart meters, right? Smart meters, there may be a missed meter reading, and we have created a rules engine that if there is a missed meter reading, it will estimate a read, right? So this is the kind of rules engine we run once we ingest the data on that platform, and then it is streamed through Kafka and then available for AI and ML as well, right? So that will give you more insights. But this is essentially a streaming data platform run on cloud, irrespective of any cloud, right? And then Fledge is a global standard for getting IoT sensors, edge devices data. So that is what we are using here. And as I said, once you have this streaming data from across, either it's a hydrogen or it's a ADMS, smart meter, work and asset management, like wherever that data is coming from, like you create a data lake and then you apply analytics, AI, ML over that data, right? And we are working on a lot of Gen AI. You must have heard this term, generative AI, right? We are working on generative AI use cases also once you have that data in those platforms. Right? Next. So these are a couple of features I talked about, right? It's open source, no licensing, nothing, no license cost, no product software you need to install. This is totally open source, scalable because it is cloud, it is scalable. It integrates with Kafka, Spark, Kubernetes, as I said. Again, open standards, industry standards on integration, JSON, MQQ, ICCP. Then Fledge I talked about. It is again a standard platform to integrate IoT sensors. And it does not only combine with, again, very data platform independently. It's not limited to IBM DB2 products, like it is always, we have done that for Snowflake, AWS, and Redshift also, which are other databases. And last one I talked about, right, our proprietary rules engine. We can create rule engines for smart meters, we already have it, and how those rules will apply to the data, validate it, and then do some estimation, and then put that on the data lake, and apply analytics and AI over that, right? So this is what we are doing is now with the clients, we are offering a proof of concepts. This is about 12 to 16 weeks of exercise. Anybody who wants to test this platform, we can work with you once for 16 weeks. 3 phases, obviously a workshop to understand your requirements, then iterative implementation, agile. Somebody talked about agile, like so requirements will change. So this is the second phase, and third phase is testing and validation of that proof of concept we can do with any organization, and we already done that with, as I said, 3 organizations. Okay, next. So this is a snapshot from Azure Marketplace. So this is, as I said, already published on Azure, Microsoft, IBM Data Hub. Anybody can go there, just search on IBM Data Hub on Azure, and you will get this similar presentation we're talking about. And the next one similarly on AWS. This is available on AWS as well, right? So this is there. Last. So these are the 3 companies where we have already tested it and implemented. It's running on their ground. To US NextEra Energy, I cannot put the name here, but it's NextEra Energy, American Electrical Power, like I saw the logo in one of the slides, previous paper, and then this one is Scotia Gas Network. So these 3 clients, it's already running, yeah, as a use case. I think why IBM is fine. Just run the video. I will just close with the video, and if there are any questions, I can take over the line. Thank you.